right, let's start going over your unit test review for sequences and series by talking about the different formulas for sequences and series. We have arithmetic sequences and arithmetic series. Arithmetic means that you are adding or subtracting to get the next term in the sequence. When I have geometric pattern, a geometric sequence or series, that means you are multiplying each time to get the next term in the sequence. One thing that I like to do to remember which formula I use for which is to put all my S words together. Series goes with sum, goes with sigma. These are all words that tell me I'm going to be adding terms up. So when I'm told to find the sum of the series or to use sigma notation, that's when I'm going to be using this S sub n, the formula for the series. That's for S. So we'll use that to keep in mind for later. The formulas with the A sub n's are my sequence formulas. They find me the rule for the sequence, or they find me a specific term in a sequence. All right, so let's look at number one. In number one, we're just asked to determine if the sequence is arithmetic, geometric, or neither. Remember, arithmetic is adding or subtracting. Geometric is multiplying, and neither would be a pattern that is not adding, subtracting, or multiplying. So it turns out that this first term is arithmetic. Now, if I want to find the common difference, which is the number that I'm adding or subtracting each time for an arithmetic sequence, I need to take the second number minus the first number. Well, 1 minus negative 1 is 2. Now let's check that. Negative 1 plus 2 gives me 1. 1 plus 2 gives me 3. 3 plus 2 gives me 5. That way I know that my sequence is arithmetic with a common difference of 2. When I look at B, I need to decide, is this arithmetic, geometric, or neither? So let's start by looking and determining if it's arithmetic. Well, if I take the first term minus the first term, I get 5. So when I check this, I say, okay, 3 plus 5 is 8. That works. But 8 plus 5 is not 9. So right there, I broke the pattern, and I know that it's automatically not arithmetic. So we go back to the starting board. Now let's talk about if it is geometric or not. So to find if it's geometric, I take the second term divided by the first term. So leave that as 8 over 3. Well, if I multiply 3 times 8 over 3, I get 8. Well, 8 times 8 over 3 ends up being 64 over 3, which is definitely not 9. So that means that this is also not geometric. Well, since it's neither one of those, that is what we will write down. It's neither arithmetic nor geometric. All right, the next sequence. The pattern ends up being geometric. Now, the way that I find this is I take the first number divided by the second number. 4 divided by 2. I simplify that to get 2 as my common ratio. Now, I need to check that. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. That pattern seems to work. That's why we're going to say this is a geometric sequence with ratio of 2. All right, finally, the last sequence here. It ends up being arithmetic again. And we double check our common difference here. I take the second number minus the first number. So negative 1 minus negative 6, that is 5. And then I check it. Negative 6 plus 5 is negative 1. Negative 1 plus 5 is 4. 4 plus 5 is 9. All right, moving on to number 2. Write the first 5 terms of an arithmetic sequence. So arithmetic tells us I'm going to be adding or subtracting, whose common difference is 10. So that means D is 10. And the fourth term is 1/16. So what I would do here is I would list out 5 blanks, and I'm just going to fill in the blanks with the terms. Well, they tell me that the fourth term is 1/16. And then it says the common difference is 10. That's positive 10. So that means as I move to the right, I need to be adding 10. So 1/16 plus 10 is 126. But now I have to move backwards. To go backwards in my sequence, I have to do the opposite of adding 10, which is subtracting 10. So 116 minus 10 is 106, minus 10 is 96, and minus 10 is 86. So that would be the first 5 terms of an arithmetic sequence with common difference of 10. Number 3 is very similar, except this time we have a geometric sequence, which is multiplication. It says I have a ratio of negative 1 over 7 and a third term of 343. So I'm going to set this up the same way. I'm going to write out 5 blanks for 5 terms. I'm going to fill in the third term being 343. So going to the right is quite easy. I'm just going to multiply by by negative 1 over 7. So I can go in my calculator, I can take 343 times negative 1 over 7, and I get negative 49. Then I take negative 49 times negative 1 over 7, and get the answer of 7. Now going backwards, I end up having to do the opposite of multiplying by negative 1 over 7, but I have to divide by negative 1 over 7. So when I divide by 343 by negative 1 over 7, I get negative 2,401. Now to go backwards again, I have to divide by negative 1 over 7, and to do that I get 16,807. So those are the first 5 terms of a geometric sequence with a common ratio of negative 1 over 7. Number 4 is similar to the last problem. We need to fill in the blanks. But what I have here is I know I have an arithmetic sequence. I also know that this is the first term, this is the second term, the third, the fourth, the fifth, and the 6th term of my sequence. Now the way I would do this problem is I know term 8, and I know that to get to 52 I have to add some common difference, some of the same number twice. So that means I take 8 plus 2d, 2 times the common difference, gets me to 52. Right? 8 plus d equals 52. Well, now, once I have that equation set up, I can solve for d. So I'm going to start by subtracting 8 from both sides. Okay. That gives me 2d equals 44. And then I get d by itself by dividing by 2. So I get a common difference of 22 here, which then helps me fill in all the blanks. So I can go from 8, and then I'm going to do plus 22, which gets me to 30. 30 plus 22, I double check, is 52, so I did it right. 52 plus 22 is 74. And plus 22 again gets me 96. Now to go backwards from 8, I have to subtract 22, so that gets me to negative 14. So my sequence is negative 14, 8, 30, 52, 74, and 96. The same kind of process is going to be used in number 5. We're going to find the missing terms of the arithmetic sequence. Well, let's use the same idea here. I know I have negative 12, and I need to add d once, twice, 3 times, 4 times, 5 times, 6 times. So 12 plus 1, 2, 3, 4, 5, 6d gets me to 468. Now again, I solve this equation for d. That'll be the common difference, and I can fill in all the blanks. So I'm going to have plus 12 to add to both sides. So 6d equals, excuse me, 480 divided by 6. And I end up with a common difference of 80 here. So now I can go into each one of these and add 80. Well, negative 12 plus 80 is 68. Plus 80 is 148. Plus 80 again, 228. plus another 80, 308, and finally plus 80 one more time is 388. All right, so this front page of the review packet was just making sure that you could tell the difference between arithmetic and geometric and how the common ratio and common differences work to get you from term to term in a sequence. Now let's start working with the formulas a little bit. I'm given the sequence 3, 7, 11, 15. Well, the first thing I have to do is decide, is this arithmetic or geometric? Well, this turns out to be an arithmetic sequence. I can tell that because it turns out that I'm adding 4 to get from term to term. So I know I have an arithmetic sequence here. Now, arithmetic sequences, the formulas are on the front of your packet, have common differences. Well, if I'm adding 4 each time, that common difference is 4. Some other information that I already can tell just by looking at the sequence is that the first term here, a sub 1, equals 3. That's information that I can write down to start. Now it says find the equation for the nth term. When I'm finding an equation for an nth term, we said at the beginning of the video that we need to use the sequence formula. And for an arithmetic sequence, it's a sub 1 plus the quantity n minus 1 times d. Well, all I need to do for this formula is to put the common difference in the first term in. I'm trying to find an equation for the nth term, so I just leave it as n otherwise. All right, so I have a sub n equals the first term, 3 plus the quantity n minus 1 times the common difference of 4. The directions tell us to simplify this equation. So to do that, I have to distribute 4 to both terms inside of the parentheses. So I end up with 3 plus 4n minus 4. And now I'm going to collect like terms. My constants here are my like term. 3 plus negative 4 is negative 1 plus 4n. That's my general formula for the nth term of this sequence. Now that formula helps me out a lot in the coming problems. I can now use that formula that we just found, a sub n equals negative 1 plus 4n, to find the 20th term. In order to find the 20th term, I just stick 20 in for n. So I'm going to find a sub 20 equals negative 1 plus 4 times 20. That gives me a value of 79. That is the 20th term of this sequence. That means if I were to write out 3, 7, 11, 15, 19, 23, on, and I wrote 20 numbers out following that pattern, the 20th number would be 79. Right? Now, part C tells me to find the sum. When I see sum, I go back to what we talked about at the beginning of the video. Sum goes with sum, series, sigma. So I want to find the sum of the first 24 terms. Well, this is an arithmetic sequence, so I need to use the series formula for arithmetic, which is n over 2 times a1 plus a sub n. Now the information I need, n. N is the number of terms that I'm adding up. Well, here it says I'm adding up 24 terms, so I'm going to use n equal to 24. I also need to know the first term of my sequence. Well, right up above, we talked about that we knew the first term of the sequence was 3. That's the first term in the pattern. Now I need to find this a sub n. Well, here we said n was 24, so that means I need to find a sub 24. I don't have that value yet, so what I do is I end up going back to the formula I found in part A, negative 1 plus 4n, in order to find the 24th term. So I'm going to find that by saying, okay, I have negative 1 plus 4 times 24. All right, to simplify that, it ends up telling me that 24th term is 95. But now I have all the information that I need in order to find of the first 24 terms. So what I do is I now take these three pieces of information and put them into the formula here. So what I have, I'm going to I think I can squeeze it in over here. All right, so I'm going to take S sub n, S sub 24 equals n over 2. N was 24 over 2 times the first term, 3, plus the 24th term we just found, 95. When I use my calculator to simplify that, it tells me that the sum of those 24 terms is 1,176. So that's the answer to part C, the sum of the first 24 terms. So if you do not know the 24th term is a sub n, you have to do a little bit of extra work to find it first. All right. Finally, express the sum of the first 501 terms using sigma notation. Now, just as express your answer, you don't have to actually find the sum. So when we have sigma notation, I have to start by writing my sigma. Now, next to sigma, I always use the sequence formula in simplified form. We found that in part A, so now all I have to do is write next to the sigma, -1 plus 4n. And then it says express the sum of the first 501 terms. Well, the first 501 starts at 1, and I'm going to count up to 501. So that's how we're going to write the sigma notation for the sum of the first 501 terms. Let's move on to number 7. Number 7, I'm given the sequence, -4 plus 8 plus -16 plus 32. We, again, just like the last problem, have to decide if this is arithmetic or geometric to start. This is a geometric sequence. I can tell that because I figure out that my common ratio here is this second number divided by the first number. 8 divided by -4, which is -2. When I multiply by -2 each time, I get the next term that they have in the sequence. -4 times -2 is 8. 8 times -2 is -16, so on and so on. Well, since this is geometric, to find the formula for the nth term, I use the geometric sequence formula, which is a sub n equals a sub 1 times r to the n minus 1. Well, to put this in my formula, I have a sub n equals, well, the first term here, a sub 1, is -4. R is my common ratio. We said by taking the second term divided by the first term, that equaled -2. And since I'm finding a formula for the nth term, I leave n alone and leave that as to the n minus 1 power. Okay, so that is the formula I'm going to use here to help me out in subsequent questions. Part B says find the 21st term. Well, I can use the formula I just found in part A to help me find the 21st term. I'm going to put 21 in for n. So I have a sub 21 equals -4 times -2 to the 21 minus 1 power. Now, when I carefully put that into my calculator with parentheses around the -2, and depending on your type of calculator, potentially parentheses around 21 minus 1, I end up getting that the 21st term is -4,194,304. Now it says to find the sum of the first 16 terms. Again, sum goes with series and sigma. So since it goes with series, I need to use the formula for geometric series. Right, so that formula is S sub n equals a sub 1 minus a sub 1 times r to the n all over 1 minus r. Now I already have all that information here, so I can put things right into my calculation. So a sub 1, again, is the first term. That's -4. I need to put this minus sign. -4 minus -4 again. Then I put r, which is -2, to the n. I'm looking for the 16th term. N equals 16. all over 1 minus r. r is -2. So yes, I need every single one of those minus signs. Very carefully, once again, I put this in my calculator. Sometimes in your calculator, you might have to put the denominator in parentheses as well. When I find the sum there, I end up getting that the sum is 87,380. Finally, I'm going to find the sum of the first 99 terms written in sigma notation. I don't have to evaluate, I just have to write sigma notation. Well, again, sigma notation, just like number 6, starts with a sigma. Then I write the sequence formula next to the sigma. Well, I found that in part A. That was -4 times -2 to the n minus 1 power. And then I'm adding up the first 99 terms. That means I'm starting my sum at the first term, going up to the 99th term. Okay? So let's do a little bit more work with sigma here. All right, let's look at number 8. Number 8 is asking us, what is the sum of the series? And that reads, the sum from 1 to 5 of -3 to the n minus 9. Show each term in the expansion. Well, we're going to, in order to find the sum and each term in the expansion, we need to put all the numbers in from 1 to 5 in for n in this pattern here. So let's see, I'm going to start with putting 1 in. So I have -3 to the first power minus 9. All right, when I simplify that, that gives me -3 minus 9, and -3 minus 9 is 12. So that's the first term in the expansion, is 12. All right, the second term in the expansion, now I put 2 in for n. So I have -3 to the second minus 9. Well, -3 squared is +9 minus 9. And 9 minus 9 equals 0. So 0 is the second term in the expansion. Third, I put 3 in for n. So I have -3 to the third minus 9. Well, -3 cubed is -27 minus 9. And that is -36. That is the third term in our expansion. We're going to do the same thing with 4 and the same thing with 5. So go to 4, -3 to the fourth minus 9. Well, -3 to the fourth is 81. Minus 9 is 72. That's the fourth term. And finally, the fifth term in the expansion, -3 to the fifth minus 9 is -243 minus 9, which equals -252. Now, if you're following along and trying to do this in your own calculator, and you're not getting the numbers -243, 81, -27, 9, -3, make sure that you are putting -3 in parentheses when you put that into your calculator. Anytime you put a negative number into your calculator that you're trying to raise to a power, it needs to be in parentheses. All right, well now in order to find the sum of the series, I now take each of these terms in the expansion and add them up. So I'm going to take 12 plus 0 plus -3 plus 72 plus -252. And when I add up all of those numbers, I get that the sum is -228. So when it tells you to show every term in the expression, you need to make sure you put all the numbers 1 through 5 in for n and then add those answers up. All right, last page here. Let's look at number 9. We're given the sequence 4, -1, 1/4, -1/16. First, determine whether this is algebraic or geometric. This is going to be a geometric expression, or geometric sequence, I'm sorry. One hint is because I'm switching signs. I go positive, negative, positive, negative. When I find the common ratio, r, remember I take the first term divided by the second term, so -1 divided by 4. That is your common ratio, and I can double check that. 4 times negative 1/4 is negative 1. Negative 1 times negative 1/4 is positive 1/4, so on and so on. Now I'm going to use this R and the fact that I have a geometric sequence here to find the 8th term of the sequence. When I'm finding the 8th term of a sequence, I have to use the A sub n formula. Right? That formula is A sub 1 times R to the n minus 1. In this pattern, A sub 1, the first term is 4. So I'm going to put 4 in here. R we calculated to be negative 1/4. And we're trying to find the 8th term. That tells me 8 is n, which goes in for my exponent. When I simplify that in my calculator, it says leave it as a fraction. I get negative 1/4096. That is a very small negative number, but that would be the 8th term in this sequence. Notice that the fractions are getting smaller as the sequence goes on. Now it says, write an expression for the sum of the first 100 terms using sigma notation. Just as in number 5 and number 4, we are going to start by writing sigma. Sigma goes with sum. Sigma, remember our phrase that sigma, sum, and series go together. So I have sigma here. All I need to do next to the sigma formula is write the expression for the nth term. Well, the expression for the nth term here would be, again, using this equation. So A sub 1, which is 4, times the common ratio of negative 1/4 to the n minus 1 power. We are writing this for the first 100 terms, which means the index on the bottom of our sigma is 1, all the way up to term 100. Right, that's all you have to do here. You do not have to find the value of that sum. All right, let's move on to number 10. We're given a sequence. The sequence is defined by A sub n equals 3n minus 5. We know A sub 1 is the first term. We want to know what is the sum of the series from 501 to the 1000th term. Well, one way to think about this is think about it in sigma notation, because we know how to compute a sum like this when it starts in sigma notation. We know we're starting at the 501st term, and we're going to add up to the 1000th term. Right? The equation that we're using is 3n minus 5. That represents an arithmetic sequence here. Now it's arithmetic because there are no exponents. The only time you're going to have a sum of a geometric sequence is when there is an exponent. So 3n minus 5 is an arithmetic pattern. Well, in order to find this sum, we have to use the series formula. Remember, sum, sigma, and series go together. So since it's arithmetic, the series formula we're going to use is n/2 times the first term plus the last term we're adding up. So first we need to find n. That's the first thing I have in my formula. N, in order to find that, we always take the top number, the top index of my sigma, minus the bottom number, plus 1. So here the top number is 1000 minus 501 plus 1. That tells me that n equals 500. So that's going to be the end. We are adding up 500 numbers of this sequence here. Okay, so that's going to go up in here. We're going to use this formula. Now I need to find the first term that I'm adding up. Well, that first term I'm adding up is term 501. That's where my sum is starting. So I need to find the 501st term. So what I do is I'm going to use this formula, the pattern, the sequence formula that I'm given, to find term 501. So that means I take 501 and I put that in for n. When I put that in for n, I end up getting that the 501st term of this pattern is 1498. So that's going to be one number that I use. Now I need to find a sub n. That's going to be the 1000th term. So I'm adding up 501 to 1000. That's the top index here. So So to find the 1,000th term, I'm going to take 3 times 1,000 minus 5. Well, that is 2,995. That's the other piece of information I need for this formula. Now I can finally put that all into the series formula for an arithmetic series. And I'll get that I have n, which was 500, divided by 2, plus the 501st term, which was 1,498, plus the 1,000th term, 2,995. When I add that up, I get that when I add up all 500 of those numbers, I get 1,123,250. Finally, let's finish out with an application problem. I have that a local pilot offers to drop the game ball for the last football game from his airplane, so up in the sky. During the first second, the football is 4.9 meters. During the second seconds, it falls 14.7 meters. During the third second, 24.5 meters. And during the fourth second, 34.3 meters. First thing I want to know, is this pattern arithmetic, geometric, or neither? Well, I'm going to list all those numbers out in order like we would a sequence. So we start with 4.9, then the next second was 14.7, then I have 24.5, and 34.3. This ends up being an arithmetic sequence. Now you have to check, you have to say, okay, well, what's the common difference, what's the common ratio? Well, remember, to find the common difference, I take the second number minus the first number. Well, when I take that second number minus the first number, I get 9.8. So I need to check to make sure that that's actually the same common difference I'm using every time. 4.9 plus 9.8 is 14.7. When I take 14.7 plus 9.8, I get 24.5. If I take 24.5 plus 9.8, I get 34.3. So it seems that this is an arithmetic pattern with a common difference of 9.8. If this pattern continues, how far will the football fall during the 15th second since it's been dropped? So what we need to do, we want to know, how far will the football fall? Well, these numbers in my sequence up here, 4.9, 14.7, 24.5, those are distances the football has fallen. So what we're trying to find is a term in the sequence, meaning that I need to use the a sub n formula, which is a sub 1 plus n minus 1 times d. Well, what I know here is that the first term, a sub 1, is 4.9. That's the first term in my sequence. I know that the common difference is 9.8. That's what we discovered in part A. And I know that the n I'm going to use, the term I'm trying to find, is 15. Now I have all the information that I can put into this formula to find the 15th term. So I will find a sub 15 here. That is 4.9 plus 15 minus 1 times 9.8. When I simplify that, I get that the football is going to fall 142.1 meters in the 15th second if the pattern continues. Now it says, what is the total distance the football has fallen? Well, total means that you have to take all those distances for 15 seconds and add them up. Adding is finding a sum. And what we've been saying the whole time here is that sum, series, and sigma go together. Well, I need to use the series formula for arithmetic, which is a sub n equals n over 2 times the first term times the last plus the last term. All right, so we have, this should be an s sub n out. S sub n equals n over 2 times a plus 1 times a1 plus a sub n. All right, let's see. So we have n is 15. That's how many seconds we're adding up, over 2. The first term was 4.9. And the distance after 15 seconds was up here. We found that as 142.1. So that's adding up all the feet that the football fell for 15 seconds. And when I put that in my calculator, I get that the football has fallen 1,102.5